So C is kind of like a conceptual question, right? So if we want to make a prediction using a value that's like 1 unit away, so if x is zero point zero 0.01 and we want to try to make an approximation of log of 1.01, so let's see what that would look like on this graph, right? So here's our zero point zero 0.01, so there's our line. If I add in, that'd be a 10, by the way. That's why the point didn't show up. Boom, there's 10. So if I did 1.01, so notice that this slope here is so steep that it's not going to do a really good job of predicting 1.01, which is going to be kind of like right here-ish on the line. All right, so our line is so steep, it's going away from this point that it's trying to predict. This would be an awful approximation. However, as my slope gets narrower, if I try to make an approximation at 11, right, so my tangent line here, this is going to be a pretty good approximation because of how kind of narrow our slope is. So we can kind of see here again that the relationship between a good linearization and a bad linearization depends on the slope of the line. If our slope is really like large, if we have a really steep slope, it tends to yield a very poor linear approximation. However, when our slope is kind of like small, kind of shallow, close to zero, it provides a really good approximation for our values. So that's kind of like the whole gist of question three. So what would be the best line? So this one here would be the best approximation of the ones that we got. That also kind of is point D, right? So the kind of like the shallower the slope, the better our prediction is going to be for linearization.